Space Agency will ring in the new year with a unique and rare launch as it gears up to launch India's first space-based astronomy observatory to study black holes and neutron stars. Now, it is a bit to understand the end of life of stars and why they still shine after their death. Now, yes, stars also die, and our very own sun is also expected to die after 5 billion years. Now, a satellite named XPoSAT, or the X-ray Polarimeter Satellite, will be launched by India's trusted rocket, the PSLV, early morning today. Now, we're expecting the launch to take place anytime soon. I'm being joined by Dr. Varun Bhallerao, astrophysicist. In just a moment, he'll also be with us. We also have Dipankar Bhattacharya, who's an astrophysicist at the Ashoka University in Sonipat, and Cheryl Mariam Jose, a student and coordinator of VSAT. Cheryl, now let me in fact start with you. How excited are you for the launch? And we're going to see a lot of startups also be involved with this.
Yes, and we are the only student satellite mission in this launch. Extremely proud and grateful that our team was able to finally put our VSAT into the space. And it was a collective effect of our seniors and juniors for the past 5 years. And when this PSLV C58 mission soars high, it's our aspiration, it's our mission. And being a women-only team developed satellite, I'm sure it would be a motivation for the students as well.
Absolutely. We'll come to that point. That's very interesting, the fact that it's a women-engineered satellite. But Dr. Bhattacharya, there's something different about this particular launch, the 4th stage. Could you take our viewers through how it's different from previous missions?
The launch itself is, of course, the payload on the mission is there are multiple satellites. One is, of course, this satellite, the student satellite that you talked about, and the main payload is the XPoSAT mission, which is for the study of neutron stars and black holes, but in particular X-ray polarization character of X-ray emission from cosmic sources. So this particular area has not been studied very well. There has been attempts to study X-ray polarization already for more than 40 years now, but it's a very difficult task. So initially, in 1970s, there was one mission which was sent by NASA. It detected a couple of sources, and the next X-ray polarization observation satellite was only recently launched in November 2021 by NASA. That's called Imaging X-ray Polarimeter Experiment, and after that it is this XPoSAT. So it is really a unique opportunity for us to study the polarized X-ray emission from astrophysical sources.
Right. Cheryl, now if you could take us through the process behind the VSAT specifically, and why that sets apart this particular mission.
Okay, so as I've mentioned, it was started off by our seniors during the 2018, by the 2018 batch, with a vision that they need to build a satellite. So that was the only mission they had then. But then after they passed out, they passed on the baton to the next batch, and it was continued. So our area of study is regarding UV radiations and UV radiance. So we'll be excavating out the live UV values in outer space, which is not available in a public domain. So that's the whole course of the motive of VSAT. And the working was, as I mentioned before, we had a faculty who was coordinating the entire work. So when different batches work within the same project, there should be a communication that should happen between these batches, and that was carried out perfectly by our faculties. I should say thanks to my faculties who coordinated this, especially Professor Lizzie Abraham, who managed the entire thing. So that was how Team VSAT was able to launch this.
Right. Dr. Bhattacharya, now the most sophisticated sort of study when it comes to space especially is the black hole, a study of the black hole, and that's something that we can expect out of this mission. Take us to the significance of that specifically.
Right. We are trying to study black holes for quite a long time now. On various missions, also some things can be observed from the ground. But the most energetic emission from black holes come in the X-ray gamma ray wavelengths, which are absorbed by our atmosphere. So we need to put detectors above the atmosphere, like in space-based platforms. And so that itself makes the study technically challenging. And but of course, there has been a lot of satellites by various agencies, including ISRO, which over the years have been trying to study black holes. This particular satellite, as I mentioned, is special because it studies a character of the X-ray emission, which has not been studied well before, and that is polarization. It's like when we receive sunlight, if the sunlight is reflected from some material on ground or water, the reflected part of the sunlight is polarized, strongly polarized. So if near black holes, there are such situations, for example, gas structures and so on, from where light can reflect or scatter, then that part of the light will be polarized. Without measuring polarization, we cannot directly resolve by existing instruments such small regions around black holes. So by studying polarization, we are able to tell whether there are these structures, what are the geometry of these structures, how this polarized emission is originating. And another major contributor to polarization is magnetic fields. Very strong magnetic fields, both near black holes as well as on neutron stars, can cause strongly polarized emission. Again, as you know, magnetic field cannot be directly observed. But by the polarized character of emission, we are able to tell both the strength and the geometry of magnetic fields. So these are things which could not be done by any other type of observation. And therefore, although there has been many missions to study black holes, these aspects have been left out. And it is a new era that is now emerging with X-ray polarization observations, which will allow us to do that. NASA's Imaging X-ray Polarimeter experiment will study it and has been studying it in certain band of X-rays. XPoSAT is going to study in yet another band of X-rays. So they will be both complementary as well as will provide greater understanding of how this radiation originates near black holes.
Right, Dr. Bhattacharya, also this mission life is about 5 years. What can we expect to learn in that span of time? And, what is the astronomy community, in fact, excited to learn about in those 5 years, the kind of information that we can gather?
Yes. To measure polarization from any of these sources, it requires collecting a lot of radiation. So typically a source, a black hole source or a neutron star source, which is emitting X-ray emission, will need to observe a single such source for a very long time, weeks together, and collect all that data together to be able to then decipher what polarization is present in this radiation.
Right.
So, although the mission life is 5 years, the number of sources that this mission will observe will be very well chosen, limited, maybe 40, 50 sources over this entire lifetime. But each of these sources will be studied in great detail, in a kind of detail that has never been done before. So, and the main things that we are looking for are, as I said, the signature of magnetic field, signature of emission geometry, signature of gas being distributed in a manner which is not completely symmetric, and the signature of reflection, signature of scattering. These are the main issues that we'll be looking at, which will tell us how the radiation that we actually see from these objects originate. There are many questions about that still, and this will certainly help answer that.
Right. Sir, stay with us. We're in fact getting live visuals, in fact, on our screen that we were just flashing for you a bit earlier. 30 or so minutes left for the launch. Also being joined by Pallav Bagla. Sir, we have Dr. Dipankar Bhattacharya, an astrophysicist at the Ashoka University. Also being joined by Sherim Alier Jose, who is a student coordinator for VSAT. If you'd like to take some questions from them as well. We were just discussing, the importance of VSAT, especially being a women-engineered satellite, and the fact that there are startups also involved in this launch makes it even more special.
Very warm welcome to our viewers, and a very warm welcome to Sherin and to Professor Dipankar, who's been looking at astrophysics for a very long time. Thanks a lot for joining us, Professor Bhattacharya. A very exciting time for India soon after the moon mission, and now the solar sun mission Aditya on its way to the sun, and now mission to explore black holes and neutron stars. What a wonderful way. And also simultaneously to have an experiment being done for students and startups in space. What a way to ring in the new year by the Indian Space Agency. And we can see the live visuals from the Sriharikota launch pad, where everything is set for a liftoff at 10 minutes past 9 o'clock. Professor Bhattacharya, exciting times for you?
Certainly. This is an area that I have myself been working on for quite a long time, and looking forward to actual observations.
Lovely. And what about you? Are the students excited at Trivandrum or Thiruvananthapuram, as you call it now?
Yes, all are excited because it was a long dream that VSAT would be launched one day, and we being students, it gives us immense pride that we were able to launch a satellite amidst all big scientists, where like Professor who is sitting here, Dr. Astrophysicist who is there. We were able to add our own payload in this mission. It makes us so special.
Pallav sir, now if we talk about this particular launch, I was just posing the same question to Dr. Bhattacharya as well. Something different about this from the previous missions is also the fourth level, the fourth stage, It's different from the previous missions. Take us through why.
Oh, certainly. This is a very important experiment which ISRO is doing, and ISRO is doing this for the third time. The fourth stage of the rocket, which would usually become space debris after having done its job, is being resurrected in a way, and experiments have been lined up on what is called the PSLV fourth stage. It's in an acronym which ISRO uses is POEM. So essentially in the new year, ISRO is going to write a poem in space, and that is where experiments from Sherin's team and the team from Thiruvananthapuram, the ladies-led satellite, is going to be launched. This particular way of doing experiments on the fourth stage is what I call a waste to wealth approach by the Indian Space Agency. Very few other space agencies have attempted doing this, and this will essentially ensure that India has a frugal, low cost, high technology experimental platform in space. And somewhere I call this a poor person's space station or a poor person's sky lab, and that is why a frugal technology, really value addition from the fourth stage to do not just one but 10 experiments. The fourth stage would have been in orbit for a while and then would have burnt up in the atmosphere when it enters. So ISRO will keep it alive. What will happen is that after putting the XPoSAT in an orbit of 650 plus kilometers, the orbit of the fourth stage of the poem will be reduced in 2 burns, and then it will be placed in an orbit closer to the Earth, and then the experiments which have been lined up, 10 of them, some of them from startups, some of them from students, some of them by ISRO itself, will be then undertaken. And value addition and high value data coming at a very low cost. Waste to wealth in space. I think the Indian Space Research Organization has mastered this art of trying to get more bang for the buck, and ISRO is certainly doing that in this maiden New Year launch of the XPoSAT satellite on the Polar Satellite Launch Vehicle, which is our workhorse rocket, and this is the 60th mission of the Polar Satellite Launch Vehicle. So it is a landmark and a milestone event for India, and coming on New Year and looking at the universe, exploring that, what a wonderful way to start 2024.